This lesson is going to be an introduction on quadratic functions and how to graph them. Standard form of a quadratic function is y equals ax squared plus bx plus c. When you graph a quadratic function, notice everything that we've graphed so far. The highest variable has been, or not variable, the highest exponent has been a 1. This time it's a 2. Because it's a 2, or a square, the exponent creates a U-shaped graph, which is called the parabola. The vertex of the parabola is either the highest point if the parabola opens up, or is the lowest point if the parabola opens down. The way you can tell if a parabola is opening up or opening down is you look at the value of a, or the coefficient of x squared. If a is positive, the parabola is going to open up and look like, a u. If the parabola is going to open down because a is negative, it's going to look like an upside down u. So let's take a look at how to graph a parabola. The first thing you have to start with is the value of the axis of symmetry. The axis of symmetry is the line that goes through the center of the parabola, the vertex, and the equation for it is x equals negative b over 2a. So let's take a look at this particular parabola, y equals x squared minus 2x minus 3. I want to find the value for the axis of symmetry, the equation for the axis of symmetry. So to find the equation of the axis of symmetry, I have to know the values of a and b. A is 1, in this case because there's no number in front here of the x squared, and b is negative 2. So to find my equation of the axis of symmetry, I have to go ahead and substitute. So I would have x equals negative b, so negative negative 2 over 2 times a, which is 2 times 1. Now this can simplify to x equals negative negative. You can't have double negative, so it becomes a positive. So the opposite of negative 2 is positive 2 over 2 times 1, which is 2. So that simplifies to x equals 1. So at the point x equals 1 on the graph, I would indicate the axis of symmetry by drawing it as a dashed or a dotted line. The next thing I would have to do is take that value that I just found for x and substitute it into the original equation to find the vertex. That will give me my value for y. So I would have y equals, we just found x was 1, so I have 1 squared minus 2 times 1 minus 3. To solve this, I would use the order of operations, so I'd have to do my exponents first. So 1 squared is 1 minus 2 times 1 minus 3. Now I have multiplication to do next, so I'd have y equals 1 minus 2 times 1, which is 2, minus 3. And the only thing left is subtraction, so I start from left to right. 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So my vertex is 1, negative 4. And then that would be a minimum point because my parabola is going to open up because the value of a is positive 1. So it'd be a minimum point. Then you want to create a table of values. Now, my axis of symmetry was x equals 1. So in order to keep the numbers on the grid and keep them kind of close together so they fit on the small piece of graph paper that we normally will use, you have to pick points that are near that value from the axis of symmetry. So our axis of symmetry was 1. I picked 2, 3, and 4 to fill in my table. So in order to figure out what the values of y were, I have to do just like what I did in the table or on the previous slide to find the vertex. So every time there's an x, I'm going to substitute it first of all in for a 2. So I would have 2 squared minus 2 times 2 minus 3. 2 squared is 4, minus 2 times 2 is 4, minus 3. 4 minus 4 is 0, minus 3 gives me negative 3. So 1 point on my parabola is going to be 2, negative 3. Then I have 3. So I'd have 3 squared minus 2 times 3 minus 3. 3 squared is 9, minus 2 times 3 is 6, minus 3. 9 minus 6 is 3, minus 3 gives me 0. So I'd have the point 3, 0. And then if I did 4, I would have 4 squared minus 2 times 4 minus 3. 4 squared is 16, minus 2 times 4 is 8, minus 3. 16 minus 8 is 8, minus 3 gives me 5. So I'd add the point 4, 5. Then I need to use my axis of symmetry to draw the curve. So let's take a look at putting the values onto the graph and what that would actually look like. So my axis of symmetry, the equation of it, remember, was x equals 1. So at the line x equals 1, I'm going to take it and draw a dashed line. My vertex was the point 1, negative 4. So I'm going to put a point at 1, negative 4. That point that you're putting there, the vertex, should be on that x-axis. And then if you recall, we made the table of values, and we had 2, 3, and 4. The values that went with the y were negative 3, 0, and 5. So I'm going to put points at those locations as well. So I have 2, negative 3, 3, 0, and 4, 5. Now I'm going to use that axis of symmetry that we drew earlier to mirror my points. So this point is on the axis of symmetry, so we're good. That's the vertex. This point is 1 to the right, so I'm putting another point exactly 1 space to the left. This one is 2 to the right, so I'm putting 1. Oops, I put it in the wrong spot. I'm putting 1 to the left. This one is 3 to the right, so I'm putting 1, 3 to the left. So now I can connect them and make my U with my arrows on the ends to make my parabola.